Well, so my purpose for today's talk is to tell you a little bit about one of my projects in which I try to identify the influence that automated accounts or bots have on social media, and in particular on the information that circulates through those networks. There is going to be three parts in this talk. I'm going to start outlining the motivation for this research. I will then give you more details about the data and the analysis. And I will finish with the so what question, that is why we should care about this research and its findings. Motivating this work, there are essentially two questions. One is about the prevalence of bot activity in online interactions and political talk. And the second is about whether traditional media are still playing a gatekeeping role in the information that circulates online. This research is part of a broader agenda in which I try to understand the consequences of having transitioned from the era of broadcasting, when the number of news sources were limited and most citizens were exposed to the same information, to the current era of network communication, which is characterized by a long tail of media options and by rising fragmentation in the supply of news and information. Now, many accounts suggest that this increased choice leads to audience fragmentation, ideological segregation, and echo chambers with no cross-cutting exposure. And some of my work tests some of those assumptions. But today, I'm going to pay attention to how those new forms of network communication are being used to coordinate and organize collective action, and to the question of whether bots are trying to hijack those collective action efforts to spread their own information. The context in which I evaluate the influence of bots in this project is given by two episodes of contentious politics. One is the Yellow Vests movement that erupted in France at the end of 2018 to demand economic justice. And the second is the mobilization around the Catalan referendum for independence from Spain, which took place in October of 2017. These two events were widely covered by mainstream media, nationally and internationally, but they also generated high volumes of social media activity, with Twitter first channeling the news that were coming out of street actions and confrontations with the police. According to journalistic accounts, and you have a few example headlines on the screen, Twitter helped fuel political feuds by enabling bots to exacerbate conflict and allowing foreign interference in the dissemination of false information. Now, of course, it is not the journalistic practice to provide the same level of empirical evidence as we researchers require, so this project was designed to test many of these claims. We know that online networks carry benefits and risks with high-stakes consequences during contentious political events like the two mobilizations that we consider. They can be tools for organization and awareness, or tools for disinformation and conflict. So what this research does is compare the attention that bot accounts receive during these events of intense political mobilization with the visibility of mainstream verified media accounts. And in particular, we want to determine if there was a discrepancy in the visibility and reach of news sources on Twitter compared to what was happening elsewhere on the web. And the web creates an information ecosystem in which bots do not have much say. And if we do find evidence of discrepancy, we want to determine if bot activity helps explain it. If some sources of information are more visible on Twitter than they are on the web in terms of reach, it could be because bots are retweeting those sources, and these sources would be much more peripheral otherwise, which is something that these headlines seem to allude to. So I'm going to tell you now about the data and the analysis, and the summary is this. We combine Twitter data and web tracking data to measure and compare the visibility of news sources on these two channels. The core of the analysis is about contextualizing the role of social media as an entry point to news. But for this, we need to first identify automated accounts or bots, which requires using machine learning classifiers. We also need to account for the content of the messages of the tweets, for which we use natural language processing. And we need to measure centrality in the diffusion of information, for which we use network science tools. And for those of you who are impatient to know, our analysis do cast doubts on the impact that bot activity had on the coverage of these mobilizations. What our findings suggest is that verified blue badge accounts were significantly more visible and central during our events. And because talks like these only allow you to say so much about data and methods, for those of you who are interested, you can find the paper online with a more thorough description of everything that I'll mention today. So this is a first take of the data that we're analyzing. We collected the data through Twitter's publicly available API by retrieving all messages that contain at least one relevant hashtag for each of the 2 mobilization events. In total, we collected more than 1 million tweets sent by hundreds of thousands of unique users. We used bot detection techniques to identify automated accounts, and we also used the verified feature to identify the accounts that the platform recognizes as being of public interest. Accounts that exhibit bot-like behavior but that are also verified by Twitter include news organizations, journalists, and public figures, and this is a category that we label with the shorthand media. So what you can see in this figure is that in both data sets, only a small fraction of all accounts involved in spreading information around these 2 mobilizations, and that's less than 1%, fall in this media category. About 4 in 10 are classified as unverified bots, and about 6 in 10 are classified as human. This figure gives us a little bit more information on longitudinal changes in the volume of Twitter messages. Panels A1 and A2 show totals in messages posted and retweets received by the 3 types of accounts, media, bots, and humans, during the Yellow Vests protests. Panels B1 and B2 show the same information during the Catalan referendum protests. In general, the ratio of messages sent by each of these 3 types of accounts does not change drastically over time, and the peaks correspond to the dates of massive mobilizations on the streets. Retweets are essential for the argument that we make in this paper because retweets are the main mechanism of information diffusion on the platform. The networks of retweets that we build with this data, however, are too large to visualize in full, and so what you have on the screen is a summary version of these networks. These are the top 10 largest communities. Every node represents a community, which in network talk means a subset of the network where connections are denser internally than externally, or in other words, the individual accounts within each community are retweeting each other more frequently. And so what we see here, first of all, is that media accounts are barely visible. There is very few of them, as we have already established. But second, we also see that human accounts and unverified bots are frequently retweeting each other. There is no clear evidence of clustering by account type, and so there's a lot of co-exposure to what bot accounts are posting on Twitter and what human accounts are posting on Twitter. Here we explore another aspect of the network, and that's the levels of reciprocity, or where reciprocal ties lie. And what we see is that this network is very asymmetrical and hierarchical, meaning there is only a small number of retweeting connections that get reciprocated. But when these ties exist, they mostly connect human accounts. And this matters because one of the ways in which bots fool humans is by pretending that they are human as well. And so if we take reciprocity as a proxy to closeness or engagement, then most of that engagement still happens between human accounts. If we look a little bit more systematically at the centrality distributions in these networks by account category, what we see is that in spite of being a minority, media accounts are significantly more central than we would expect by chance in both mobilizations. We also see that humans are significantly less central than we would expect, and that bots are generating many of the retweets granting centrality. And so what you see here, the box plots summarize the values obtained from permutations of the data where the category labels are randomly reshuffled. And so departure from randomness means that the observed values fall outside the permutation box plots. Now, everything that I've discussed so far derives from the Twitter data set. As I mentioned before, we also analyze web tracking data, and in particular, we look at the audience reach of media sites on the web. Percentage reach refers to the fraction of the online population in France and in Spain, respectively, that access a given media site during the period in which these mobilizations took place. And so essentially, this figure allows us to identify the news sites that acted as the main sources of information online during the mobilizations. One of the things that we see is that news consumption is more concentrated in France, and it is also a less frequent activity among the online population. Only 5% of all news sites have an audience reach of 13% or higher, with a maximum of 41%, which means that less than half of the online population in France were consuming news on the web in this particular time period. In Spain, only 5% of all news sites have an audience reach of 32% or higher, with a maximum of 66% for the most read newspaper. And these numbers suggest that the overall levels of user engagement with digital news is not that high or evenly distributed. In any case, what matters here is that with this data, we have a ranking of legitimate news sources ranked according to their visibility and audience reach. And so our next question is, do these sources also attain similar visibility on Twitter? Here we have the correlation of rank position in percentage reach on the web and retweet centrality. The scatter plots on the left column measure the association between audience reach on the web and number of followers on Twitter, but the more interesting scatter plots are on the right, and they measure the association of reach with number of retweets received in the stream of information specifically related to the protest. And what we say is that the correlation is rather weak. So the most accessed news sources on the web are not the most salient in the Twitter stream covering the mobilizations. And this begs the question, are bots responsible for this discrepancy? This is the question that this figure aims to answer. Here we look at whether the difference in visibility rankings correlates with the number of bots retweeting those sources. And we do this by looking at the neighborhood in the retweet network of these media outlets. Outlets above the zero line have better ranking on Twitter. Outlets below the zero line have better ranking on the web. And the horizontal axis measure the number of unverified bots retweeting these outlets. And as we see, there seems to be a moderate correlation, meaning that the more bots are retweeting these sources, the higher the discrepancy of the Twitter visibility is. But once we control for the size of the neighborhood, in other words, once we control for the presence of human accounts also retweeting those sources, the correlation disappears, meaning human accounts are also responsible for generating this discrepancy. We also wanted to take into account the nature of the messages tweeted and retweeted, and we did this by quantifying the sentiment of each tweet. And so for this, we used a well-established natural language processing technique that is specifically designed to analyze sentiments expressed in social media. By design, the original version of this technique is built to analyze English text. And so we modified it to support sentiment analysis of text that also includes Spanish, Catalan, and French. This figure shows the distribution of these sentiment scores, which range from -1, which means extremely negative sentiment, to +1, which means extremely positive sentiment, with 0 values representing neutral messages. And so with this information and all the other information I already discussed, we used mixed effects models at the message level to identify the factors that predict the number of retweets that messages received during these protests. Messages are nested within unique users, so we use account ID as the random effect, which also allows us to control for unmeasured characteristics at the user level. Our fixed effects include 3 controlled variables: number of followers, number of friends, and the sentiment score of the messages, and 2 explanatory variables, namely whether the account posting the messages is classified as media or as human, with bots as the base category. As a robustness test, we fitted these models with and without neutral messages in the data. So remember, those are messages that have a sentiment score of 0, and with and without a binary variable identifying accounts that are also present in our web tracking data. So these would be the legitimate news sources. And these figures show the results. Controlling by structure and content and random variability at the account level, messages published by media accounts receive more retweets than messages published by unverified bots, which is the base category, but also messages posted by human accounts receive less diffusion. Controlling for all these things, the subset of news organizations for which we have web tracking data also receive less attention than verified media accounts. And this is an effect that is particularly strong during the Catalan referendum, and it highlights the power that social media has to challenge gatekeeping, traditional gatekeeping roles. So let me step back now and give a summary of what this all means. First, we show that verified accounts are more likely to receive retweets, and therefore that they were reference points in the coverage of the mobilizations. Their messages actually received more attention than news outlets with sustained traffic on the web. And we also show that bot activity is not responsible for creating discrepancies in the visibility of news outlets. If anything, human retweeting is more important in amplifying differences of visibility in social media compared to the web. Based on these observational data, it is not possible to determine if these interactions and types of exposure had any effects on opinions and attitudes. And likewise, it is also difficult to determine if exposure to other media content on the web, or more generally in the wider news ecosystem, can counteract the effects of exposure on Twitter. However, we do find little evidence that bots manage to gain comparable prominence to verified media accounts. These findings also highlight the importance of clearly defining the policies that underlie the verification process of social media accounts. There is abundant evidence that misleading information is often spread from verified accounts, including those of government officials and recognized public figures. Verified accounts have also amplified the messages of dubious sources that would be fringe and less visible otherwise. And so what our results suggest is that we need to pay more attention to the complex relationships that emerge in the interactions of verified accounts with other user accounts, because in the end, effective disinformation campaigns involve a range of different participants, and the actors behind those campaigns work around platform policies, including public verification programs. More generally, given the impact that misinformation can have on democracies, it is important to understand the role that bots play in the dissemination of news, especially in the context of contentious political events, which are particularly volatile and susceptible to misinformation. However, it is also important to contextualize the role of bots in the broader media landscape. Social media, at the end of the day, is just one layer of communication in a much more complex media environment. And this takes me to my last slide, which is about next steps. So what's next? How can we push this research area further? Well, one of the big difficulties we confront today is not only that the media landscape has become way more decentralized than it used to be. It is also that information is flowing through all these parallel channels, the web, social media, TV, radio. And not only are we far from measuring in accurate and reliable ways exposure in each of these channels, but we are even farther from understanding spillover effects. Only about 20 to 25% of the online population is on Twitter, but journalists are overwhelmingly on Twitter, and whatever happens on Twitter will percolate to what we watch on TV or what we read in our traditional newspapers, and we are far from understanding those dynamics. The other big problem is not so much what digital technologies do to our news exposure, but how they allow us to opt out. And this is the choice that a large fraction of the online population seems to be making. One of the priorities to my mind for future research is to look at this huge chunk of the online population that do not seem that interested in legitimate news, and ask, so where are they getting their information? And are they more vulnerable to misinformation campaigns and manipulation efforts? And to answer this question, the bottom line is that we still need to do a lot of work, but we are already doing it. And I'm going to leave it here.